Water is the most abundant molecule on Earth. So abundant, in fact, that if Earth lost 10 trillion drops of water every second, it would take over 80,000 years for Earth to lose all of its water. Of course, this isn't too surprising since Earth's water weighs over 1.5 quintillion tons, which, believe it or not, is only about 0.0002% of all Earth's mass, although every cloud in the sky weighs around 1 million tons. So they're not actually light and fluffy at all, they are heavy and fluffy, which doesn't make any sense. Anyway, water is the only substance on Earth that can be naturally found in 3 forms, the 3 forms being liquid, solid, and gas. When it's in its liquid form, it's typically referred to as water. You didn't know that, right? In its solid form, it's typically referred to as ice. That was news to absolutely no one. And in its gaseous form, it's typically referred to as water vapor, or steam. Of course, its gas form has nothing to do with gasoline. Don't get those two confused, or you'll end up with a worse situation than that time you tried to use a laser pointer as a jack. Oh, and remember how there's like some 1.5 quintillion tons of water on Earth? Well, most of that water is actually salt water. 97.5% to be not exact, but as close to exact as science can figure. If you want some fresh water, you've got to head over to Antarctica, where some 70% of our fresh water is. Now, don't get confused, there's not like a giant freshwater lake in Antarctica. Oh no, it's far too cold for that. All that freshwater is located in the 7.2 million cubic miles of ice there. Most of Earth's freshwater is frozen. 30% of the Earth's freshwater is located in the ground, in the form of, you guessed it, groundwater. Oh, and we can't forget the billions of lakes and rivers that make up a whole 0.1% of the Earth's water. And, rather shockingly, this nearly invisible and tasteless liquid can dissolve more substances than any other liquid on the planet. It can even dissolve metals, hence why it's often referred to as the universal solvent. Of course, it can't dissolve everything. I mean, if you put some oil in water, you'll find that out pretty quickly. Now, while it can dissolve metal, it's important to note that most metals will only dissolve slightly in water. This is because after some time, there was a coating formed around the metal known as rust. And of course, rust largely protects the inner metal from the water. When referring to water here, we're referring to pure water. Pure water is simply H2O, which, by the way, does not mean that it converts hamsters to ostriches. It simply means that there are 2 hydrogen atoms and 1 oxygen atom in 1 water molecule. There are about 1.56 sextillion water molecules in 1 drop of water, which means that there are about 7 septillion molecules in 1 glass of water, about 3 undecillion molecules in a lake, and about 5 octodecillion molecules on Earth. Don't worry about remembering those numbers though. Just remember that pure water has a pH of around 7. For comparison, lemon juice has a pH of around 2, and soap has a pH of around 10. The pH, of course, representing potential hydrogen, which probably didn't help any. Just know that pH represents the acidity of the substance. The lower the pH, the higher the acidity, and the higher the pH, the lower the acidity. 0 being the lowest pH, and 14 being the highest pH. When frozen, water expands by about 9%. Actually, that's a very pathetically simple way of putting it, but we'll get to that a bit later. When water expands, it can create enormous pressure. So much pressure, in fact, that if you filled an iron sphere with water and then froze it, the water would expand and the iron sphere would explode. That is quite some energy. Anyway, back to the pathetically simple 9% expansion statement. Most liquids, such as paraffin wax and oil, get more dense when cooled, and water, as a liquid, also gets more dense as it cools. You're probably now confused as to why it expands, but it also shrinks. This is because water shrinks in volume until about 40 degrees Fahrenheit. Then the water suddenly stops condensing, or shrinking, and begins expanding. As it expands, it of course gets less dense. This is the reason why ice floats on the surface, and because it floats on the surface, it keeps much of the water underneath from further freezing. Water is the only liquid on the entire planet that expands when frozen, and if it weren't for this amazing singularity in its design, ice would simply sink and more ice would form on the surface. This would continue until all the streams, ponds, lakes, rivers, and even the ocean were completely frozen, and the Earth would become a massive ball of ice.